Hello, everybody. So now we have speaker Nigel Choi, who is currently the head of engineering at Eythos, which is a tech-enabled fine arts service company in Hong Kong, was an alumni at Stanford University for computer science, and is currently an active member of Dim Sum Labs, which is Hong Kong's longest-running hackerspace. Today, he's here to talk about Hackman, an IoT and membership platform on Raspberry Pi, and Nix for Hong Kong's first hackerspace.
Hello. Hey. All right. Thank you, everyone, for coming. And I have to admit, I just whipped up these slides like this morning, so been very busy. And the topic is still Hackman, but it's more Nix than Hackman, and you know what I mean. That's the topic for today. First, I gotta plug Dim Sum Labs because in the awesome space, we have a member there, more. And then I'm gonna talk about Hackman in general, and then talk about the problems that you all have, right? Package management, which we encounter with Hackman. And then I'm gonna talk about Nix and how it would solve that problem, at least theoretically. And then I'm gonna plug Dim Sum Labs again. Now, okay, Dim Sum Labs. What is it? It's Hong Kong's longest running hackerspace. And you might ask, what is a hackerspace? It's kind of like a makerspace, but it's for hackers, I guess. Actually, I don't know the difference, but it's kind of a makerspace. You pay a membership fee, you go in, you use your all the equipment, and more importantly, meet other people, right? Given this is a Python conference, there's a lot of AI talk. I gotta put some AI in there, and this slide I asked ChatGPT to make, and that's what it says. All right. Second slide, also for Dim Sum Labs. If you like to make things, physical things, software, hack, come join us. You don't have to be a member. We open our doors every Tuesday. Come join us in Shanwan. We have 3D printers, we have laser cutters, we have CNC machines, soldering irons, lots of free electronic components, and we have LED lights that are custom, and it has a pink hue. So, at least the old ones anyway. We are replacing them. And you meet a lot of nice and awesome people like all you guys. Talk tech, talk shop. It's fantastic. All right, now getting into the main topic for today. Hackman. What is Hackman? Now, this being a hackerspace, we do everything ourselves, including the door access. The door locks is actually custom hardware that runs on a Raspberry Pi. And I'm just going to tell you, the Raspberry Pi stores our entire membership database, and it actually hangs on the wall in the space. Telling you that is, some of you might go in and try to hack it, but we password protect it, obviously, but challenge. Originally, what I had planned for this talk is to showcase a new version of Hackman that runs in, I can show you this. Let's say, where's my mouse? Here you go. Can you see this? No? I guess I cannot move my mouse to the other one. There you go. Okay. Okay. That's the thing that I was going to hack up and show you guys a demo of how you can unlock doors, from a Raspberry Pi, but live, and I wasn't able to do it. But as you can see, this new version, it runs on Raspberry Pi 5. Has an SSD, has a battery backup, and has a screen. I was gonna rig this up to show you today, but didn't have enough time. So I'm just gonna go through the slides and show you more about Nix than the actual hardware. But oh, what happened? There you go. Did that just happen? Okay. Were you able to see? Was it disappearing for a bit?
No,
It's okay. Okay. All right. Now. Okay, back to this. Now the current Hackman still runs on a Raspberry Pi 3 and it's showing its age. If you go to door.dimsumlabs.com, that's the website that's hosted on the Raspberry Pi 3. So don't go and DDoS it because you can't handle it for sure. And the way it works is you go to door.dimsumlabs.com, you can register for an account, and if we find that you are a paid member based on your email, there's a button that says open the door, and you can then open the door. So I can actually show you here. Yeah. Oh wait. Oh, it's the screen. Well, that's the screen right now. That's in front of the door. But yeah, so that's it. You can log in. Oh, maybe I don't want to do it. Anyways. Okay. Go. It's a little slow, but you. All right, maybe I don't want to wait for it. Okay. Anyways, so the software inside the Raspberry Pi, well, it runs the standard Raspberry Pi OS, and on top it runs Django, and the package manager is Poetry, and that brings us to today's main topic, because developing for it is kind of a pain. So if you want to clone our repository and run it yourself, it's a pain to set up. And you all have probably very similar experiences with all other kinds of repository, right? When you start developing a project, you have to go set up your machine and so on. And I have to say, I hate package managers. I mean, they're trying to help. Don't make me wrong, but I like them until they make my hair, make me pull my hair out. I mean, not that I have much. You've seen this, right? You upgrade one package and find, other packages in your system no longer works. It's so easy to make many changes when you're in the command line. It's just, you did something and you forgot about it, and next time you try to set up something else, you say, wait, why didn't it work? Oh, I did that, I forgot. And then you upgrade something and it doesn't work and you can't roll back. Your team develop things, lots of dependencies, waste a lot of time setting up. That's a very common problem. I mean, a lot of these package managers try to solve them, but kind of in their own system. And that's what I'm talking about. Like all of these systems, they all have their own package managers, right? Like Python, but Python has a package manager. Yeah, pip is great as long as you stay, purely in Python land. As long as you need to compile anything in C or whatnot, okay, things start to, all hell's break loose, right? And then you start to get into, operating system packages like apps, RPM, yum, and then, it's just dependency hell, right? And on top of pip, people also try to, build, more sort of quality of life, systems like Poetry, which is great. I love them, but trying to get all of these working is difficult, right? So then I discovered a solution called Nix, and when I try it, and as long as I can get it to work, and that's the key. When I get it to work, it's actually really good, because once I set up a config file, I can just replicate it in whatever systems I want to. Especially if you use NixOS, you literally can just have one command and replicate everything and have your environment set up exactly the way you want it. Now, getting that set up is difficult, and I'll get to it. So the central idea is, with Nix, you don't do command line things or even shell scripting. You actually declare how you want your system to look, and when it runs like it's purely functional, meaning nothing gets overwritten. You always append to things. All the past history is kept to some degree. Anyways, you can't keep things forever, and it's really a configuration and package management system, right? Now, so the benefits is, right, you can reproduce it. It's very precisely reproducible, right? I mean, you might have experience with Docker and say, yeah, Docker can reproduce, but what's special about this? Now with Docker, if you don't set up your Docker file right, or you don't specifically pin your dependencies versions, you still get into these dependency hell, right? The same Docker file can generate different outputs in different systems, right? With Nix, as long as you have the Nix file and Flake or whatnot, you run it, you get exactly the same thing every single time, right? If you need to roll back, it's very cheap, because history is there, just roll back, right? And really nothing is overwritten, because everything is immutable, right? You upgrade, a new version is created, so nothing is overwritten or upgraded, updated in place, right? So I think enough of slides. I can kind of show you how it works, right? So demo time. Now, before I get into the demo, this one idea that I really like about Python, and that is called virtual environment. Meaning, say you go into a directory, you can have in runtime, in your development environment, load a virtual environment, and you have all your necessary Python packages loaded into your environment. And when you exit it, everything is gone. So you wouldn't say install Python packages at the system level, right? You only do it at the project level, and it keeps your so development environment clean. So I like that idea really very much. So Nix actually takes that idea, or at least Nix packages, takes that idea and applies it not just to Python, but to basically as much operating system packages, binary packages as you can. And the way you do it is you use Nix's package manager. You use something called dir-env, which I would just show you. You go into a directory, it loads all the dependencies, and then in that environment you can set up poetry and whatnot, and it'll just handle all the Python packages. So demo time. And let me just do that. Okay. Is it a little dark? I think it's a little dark. Oh. Can you see this?
Yeah.
Yeah. It's a bit dark. So, what do you have? Okay. Oh, cool.
6. Oh.
that's what it's always fun doing live coding. And I should change my screen so that it's space. Go. Just do a mirror. Okay. All right. Is it big enough? Okay, good. So I have a project like under my code directory, not very visible, but anyways, a project called lolcat, kind of a thing. So I'm going to show you when I go into this folder. Well, by the way, anyways, this is a Mac, so I think it's brew list. I have no brew, like no folders. Font is white, sorry. So that. There you go. OGB black. There you go. Good. Okay. All right. So my operating system is clean, right? No extra. You know, I've seen sort of get rid of brew because Nix is just so useful. What I do is you go into, say, a folder. It is a project. You see, when I go in, it tries to load all the environments, and there it goes. And now I have, you know, like cow. Okay. Cow say. So there's a there's a command called calsay, right? That's actually loaded in this shell. So how does it work, right? So if I go up, try to do the same thing, none. You see what I did there? There's you go in there and it loads just what the project needs, and that's it. Okay. No polluting your general shell and all that, right? How does it work? Okay, two files they're crucial, ls-la. One is called .envrc, that's from dir-env. One is called shell.nix, that's the proper Nix the setting. So let's look at let's look at the .envrc. All it does is just one line, right? Use Nix. This does require one binary installed in the system level. It's called dir-env, but it's mostly harmless, right? And that's just one, right? So what it does is you hook it into your shell, and when you seed it into a folder with an envrc, it will read this file and do whatever you tell it to. And in this case, I'm telling it to just use Nix as the package manager and load all the environment that's specified in the Nix file. And the Nix file is called shell.nix. And this is where you would define all the system packages, even the Python version. I can say Python 3.9. Like here, this is where the magic is. Some projects might need Python 3.9 or older versions. Some projects might need Python 3.12. Before, it's like a huge mess if you want to do it. Here, you just define it here in different projects, and it'll just pull in whatever is needed. Okay. I defined all the other binaries or packages that I need, right? All right here, and these are packages, sort of wrapped packages by Nix OS, and you can find them in search.nixos.org. So Nix boasts that they have the largest package repository in the world, which is true because their package is like a package of all packages, right? So it includes all the Python packages, all the OS packages, everything. Sometimes it gets a little hairy, but for the most part, it actually works, which is awesome, right? And then you can define, what you want when you say enter into the shell, right? So shell hook, you know, the bow file that I just showed you right now, you know, this thing. It's actually kind of another interesting thing called ICAD. It takes an image file and turns it into sort of command line ASCII. So that's what it does really. So when you go in, you see it actually actually loads it, right? So you can do a lot of things. You know, when you go in the directory, you know, you need to work on a project, you can run you know, scripts for you, right? So let's do an interesting exercise. What's a tool that you like to use? Anyone? Give me a command or tool that you use a lot. Anyone? Well, you don't code? Come on.
Let's try FFmpeg.
Huh?
FFmpeg.
FFmpeg. Let's see if that works. Oh, this might be really challenging, but we'll see. All right, now it's going. And yeah, it found it. Okay, cool. All right, I didn't have to find the name, so that's good. All right, and that was a little slow, and it's going. Oh, done. You don't even have to compile, because it's pre-compiled. It's a Mac, so a lot of people have compiled it on a Mac, so it catches it and just pull down the binary. Done. And what is command FFmpeg? Oh yeah, there you go. FFmpeg. Okay, what's FFmpeg? What do you do with it?
Yeah, edit videos.
Okay. Oh, it has a Windows. Yes.
Video usually.
Oh, there you go. Okay. Oh wow. Okay. I guess it works. Oh, that's it. Super easy, right? Before, you know, when you need to do this, you have to pull down the package. You might have to compile, and God forbid there's a dependency it needs, and you have to do all the setup. You don't have to, as long as Nix has it. And from my experience, a lot of times Nix has it because someone somewhere in the world has done it and contributed back to the package. Makes it super simple. Right, so that's what I want to show you today for on the awesomeness of Nix. All right, so I gotta go back to where, there you go, my slides. All right, so I hope I convinced you that it is nice, okay? Now, what does it have to do with Hackman, like what I just showed you? Imagine that, I mean, that is running in my Mac, so I'm not changing my Mac's OS. But imagine that, ooh. This is very, imagine that, there, okay. Imagine that, but apply it OS level, right? So you have a shell.nix, it's actually not shell.nix, it's a flake file, or not, I won't get into the technicalities, but you define literally your entire operating system with what packages, users, even SSH keys, everything in one file, or a set of files you want to be modular, and you run it, and it installs the operating system exactly as you intended it to. Especially if you have, you know, standard hardware like a Raspberry Pi. So once you have that, forget about, you know, having to log in and do a menu setup. You know, just run that command done. Right? That's the idea, right? And it makes, if we ever have a team to build Hackman, then we get everyone in the team a Raspberry Pi and go set up, and they can have it running in, you know, maybe an hour or two, instead of spending 2 days setting up your environment and doing all that stuff. Anyways, that's the idea anyways, right? But I haven't gotten into, okay, how do you set up Nix? That's actually the tricky part, because to really define that file, there's a lot of trial and error and so on. But the key is, once you define it, it's done. And you don't have to worry about doing manual stuff later on. Okay. That's about it, and I have 4 minutes. Any questions, concerns, anything you want me to show? All right. Really all good? No, nothing? Okay. Final plug, come join us at Dim Sum Labs. That's actually my main purpose for today. Thank you.